Good afternoon. Apparently Matt is much more confident than I am. I actually brought a sample of one of his rubber products with me in case anybody wants to examine it later on. I don't go anywhere without a bag of tricks. My name's Deb Mielewsk. I've been at Ford for 25 years. Technical leader of plastics research, worked in plastics all my life, and totally energized at this whole idea of sustainable materials, especially for plastics and Ford vehicles. I'm here in support of Matt, who is sort of the star in this rubber material, but I am going to expose you to some of the things we are working on at Ford and have accomplished in the past. Now I'm going way, way back. If you work at Ford, you have to show this slide. Okay, so Henry Ford, a big, big avid supporter of using agricultural products in vehicles way back then, so I am nothing more than a copycat. He believed that the partnership between agriculture and industry was a natural one, and that we could utilize each other's products and support one another in our industries. In 1937, Henry Ford was producing 300,000 gallons of soy oil a year for use in car enamel or paint. We're looking at that technology again today, so a lesson learned: if something doesn't work the first time, wait about 80 years, try it again. In '39, Ford Motor Company was harvesting their own soybeans, 100,000 bushels in Dearborn. He worked very hard on a soybean car, which is in the picture there. He's with one of his chief scientists in that picture, and it was unveiled in 1941. And he also used wheat straw, which is a byproduct of growing wheat, and something that I did the past 5 years, not knowing that Henry Ford had already done it in the past. As soon as I look online at a new idea, Ford already did it. So here's, speed it up to today so you're not here forever. Here's our CEO right now, Alan Mulally, and everybody loves him. He brought Ford back in quality, and he's an awesome businessman, but he also is very interested in supporting environmental technologies. So we have Bill Ford, very active within the company, grandson of Henry Ford. He's always been supportive as well of our projects. So one of the important things that we've done at Ford over the past year is to develop our own materials strategy. It's fine to say, you know, a little group of scientists at the research center are developing some green materials, and maybe we'll use them, maybe we won't. But in this case, we have world headquarters actually establishing a vision, rolling out our vision to the engineering program teams, and requiring that the programs increase both their sustainable and recyclable content every single year. So I think this is really important. It says that recycled and renewable materials must be selected whenever technically and economically feasible. Okay, we leave the loophole for economically feasible, but we've made good progress even with that restraint. We'll encourage the best green technologies to meet increasing demand. When we use these materials, we want no compromise in quality or durability or performance. We want them to meet every single specification. And I think that's really important. If you launch something that doesn't perform for the customer, performs poorly, they have to go back to a dealer and get it replaced, you'll never be able to do it again. So we've been very careful to meet every single requirement. And then the use of recycled and renewable content will be increased by every single program every year. And I'll be a part of sitting down with all the program teams and talking to them about what the material options are, what's proven out, and what we can migrate to all of our materials so that when we launch something, we actually use millions of pounds a year. So here's my portfolio. We started this research in 2000, and at that time I got thrown out of every conference room at the Ford Motor Company because everybody said, green materials, are you kidding me? Get out of here. Over the past couple of years, of course, now I'm popular. So I called the bottom bright green quadrant all things soy. We looked at soy foams. And see, I have to bring my bag of tricks. This is the first sample of soy foam where we tried to incorporate 1% soy oil into a foam, and it's just miserable, absolutely miserable. But after 5 or 6 years worth of work in the laboratory with a really good chemist, we met every single specification. So I like to bring these because it reminds me it's a long road. When you start a research project, expect bad results. expect these materials to smell, to give off volatiles, but you can figure out ways to address this and to make it cost effective as well. So keep persistent. The second quadrant is natural fibers. We're focused on using any kind of natural fiber, coconut coir, grasses, hemp, flax, to reinforce plastic materials or composites. And I think there's a space in automotive for all of these fibers. So we have materials that have very low function, like bins, all the way up to high function semi-structural components on vehicles. So we're looking at them all. And then the last, which is bio-based resins. I'll probably be retired when we put those into production. But we're looking at PLA type materials. They have durability issues, but our job is to be creative and address those durability issues, try and get them into vehicles. So here's one slide on the success of soy foam that's utilizing the functionalized soy oil in foams in cars. Right now we have every single vehicle in North America that Ford builds has seat cushions and backs that include soy oil in them. Over 3 million vehicles on the road today have soy foam seats, and I'll knock on wood, not one issue with those soy foam seats with performance or durability. 75% of our headrests contain soy, and it's actually at a higher percentage, it's 25% soy oil in them, and we're reducing petroleum usage by about 3 million pounds and CO2 emissions by about 20 million pounds, just using one little technology that was developed in one little lab in Dearborn. Why were we successful? Partnering, partnering, partnering. And so our partnerships included universities for all of the projects. Farmers have been some of the most important contributors to our research portfolio. Chemical companies, resin producers, compounders, and then of course the tier ones that supply the parts to us, and even other OEMs. So the more partnerships we form, the more different ideas come to being, and the more things we think we can launch at equivalent cost. The OARDC partnership, it's an interesting story. I'm a 3-time over Wolverine. So one day I got a letter from Bill Ford in my mailbox. It made me want to throw up. Because I'm a second child, I'm always in trouble. So I looked at the letter and I'm like, oh my God, I'm not going to open it. I must have done something wrong. So I waited a day, came back, opened it up. Bill Ford had received a letter from a dealer, one of our car dealers in Wooster, Ohio. And the dealer said, are you guys aware of what's going on at OARDC? And so Bill Ford saw this and sent it to me and said, you better check this out. So I said, the Buckeyes? Really? I got to go there? So my group and I took a trip, and we were totally wowed, totally impressed by all the cool things that were going on at the OARDC. So that's where the partnership initiated, from a dealer's idea, sending a note to Bill Ford, and then his sort of follow-up in sending his staff to take a look. So anyway, what's our interest in Waiuli and Russian dandelion? We use a ton of rubber-modified plastics in Ford vehicles. So TPO materials, TEO materials have either natural rubber or synthetic rubber in them. So we thought it would be great to be able to replace that rubber with something we can grow in this country. So what are we going to do? We're going to take the Waiuli or the dandelion rubber, and we're going to use it as an impact modifier in both polypropylene and PLA materials. PLA suffers from brittleness, and so this may improve that. So we're formulating our polypropylenes and our PLAs with different amounts of Waiuli and comparing it to traditional automotive TPOs. Now, keep in mind, the traditional automotive TPOs have 25 years of formulation work behind them. So the Waiuli is really, really sticky stuff. Nothing like handling EPDM rubber. So we have somebody who learned how to cryogrind it in liquid nitrogen, and create something more like a fluff that can be handled in the lab. Uh-oh, I'm stuck. There we go. And then, luckily, we have processing equipment at Ford where we can extrude, compound the Waiuli or the dandelion rubber with a plastic material, injection mold it at various temperatures, find out what the good temperature windows are, and then eventually test the mechanical properties. So some of the things that are important to us for a first screening of a material are flexural properties, tensile properties, and of course notched IZOD type properties and impact. So here's the only slide I have with results because we have one sample of the Waiuli at this point. We put it into a couple of different polypropylene materials, and you can see with 20% Waiuli, the last set of bars, I don't have my pointer here. Hold on. It's not showing up. Okay, the first one is polypropylene itself. Not great IZOD impact. The next two are typical TPO materials that we currently use in automotive, and the third is a polypropylene modified with the Waiuli instead of our standard rubber. And you can see that we're pleasantly surprised. We're already up at 14 kilojoules per meter squared on our impact, and we have done nothing more than get the material in at 20%. So what's our next steps? We're going to increase the loading of Waiuli to 30% in polypropylene, see if we get it up to the one of the TPO samples. And then we're going to do Dynatop impact testing, which is 5 mile-an-hour impact testing, very important for assessment for crash purposes. And then hopefully we'll receive a sample of the dandelion rubber soon, and we'll run through the whole set of experiments with that as well. We'll modify the PP with Waiuli and natural fibers. Since we're working on those, why not use the natural fiber as a stiffener while the Waiuli improves the impact? And then we'll track the scale up and we'll perform larger trials on actual parts. And that's it.